you get an automatic message in Teams when I press the start button for recording. So once again, today's topics are thermocouples includes types, use, and calibration. These are the following topics: thermocouple types, types of contacting, calibration, creation of TCT files, and FAQs. The first thermocouple, type N. The material on the plus side, nickel, chrome, silicon. On the minus side, nickel and silicon. Application range from -270 to +1300 degrees. And the color code is pink. The next one is type K. Materials on the plus side, nickel and chrome, and on the minus side, nickel. Application range also from -270 to +1300 degrees Celsius. This color code is green. Next one, type S with Inconel 600 centering guide tube. The materials are on the plus side platinum and 13% rhodium, on the minus side platinum. Application range is from -50 to +1786 degrees Celsius. The jacket here you see is Inconel 600 centering guide tube. The color code is orange. Next thermocouple, type S with ceramic sheath. The material is also on the plus side platinum and 13% rhodium, on the minus side platinum. Application range -50 to +1786 degrees Celsius. The sheeting is ceramic sheath. The color code is also orange. Next one, thermocouple S with ceramic insulation. Also the material is on the plus side platinum and 13% rhodium, on the minus side platinum. Application range from -50 to +1786 degrees Celsius. Here is the jacket, ceramic insulation, and the color code is orange. Here you can see a summary of the thermocouples. You see here the materials, the types, the application, the classes, and on the right side there are the color codes. Here you can see the plus, the minus side for each type.
I have a quick question. The color codes, are they an international standard or is that just a SWICROL standard?
No, this is international standard.
Okay, thank you.
So types of contacting: contacting by means of displayment unit, direct fixing with high temperature binding wire, and measurement close to sample. To achieve accurate temperature control on the specimen, good contact must be ensured. Conducting by means the displacement unit. Here you see in the upper side the displacement unit with fixed distance, and below here you can see the shift unit adjustable. Linear displacement unit. Linear displacement mechanisms enables the radial spring load positioning of the thermocouples. Designed with fixed scanning distance for furnace with continuous hang rod. Designed with variable scanning distance for furnace with cycle support. The advantages: simple handling, guides leave for round specimen available, and easy scanning possible on flat specimen. The disadvantages: shell thermocouples are easily bent and often get stuck in the ceramic pipe. Distance of the measuring junction of the specimen not allowed defined if not welded with the shell. Sideways scanning of the specimen leads to the specimen moving if the preload is too low. And the adjustment and maintenance: adjusting the scanning position, adjusting the scanning force, and a calibration. So here we have the installation of the thermocouple. I will show you a small movie. The thermocouple is placed in the shifting unit and is fixed with a screw. Adjusting the shifting unit. This is also a small movie. By opening the two nuts, the TC unit can be adjusted in high and laterally into the center of the furnace. With the supplied tool from Mitec, you can adjust the height of the unit. At this position, it is possible to set the spreading of the thermocouples. Contacting by means of displacement unit, thermocouples with and without centering tube. Here you can see displacement unit with fixed distance on a round or on a flat specimen. Shift and unit adjustable, also on a round and a fixed a flat specimen. And here you can see shift unit adjustable with ceramic thermocouple. Here are the types, the temperatures, yes. Attach the thermocouples. This is also a small movie. Now you can bring the furnace to the center and fix the furnace swivel. Open the furnace. Open the two pull rod coupling. insert the bull rod with the specimen, close the bull rod coupling, open the screw and push the thermocouple unit until it contacts at the specimen. And then you also close the furnace. On this page, we can see the contact pressure of the thermocouple should be between the two green lines. This is here you can see. Preparation of thermocouples at Zwickrell Fürstenfeld. Cut the wire 2 centimeters in front of this isolation. X-cross the wire as shown in the picture here. Choose the correct setting on your thermocouple welder. Here you mean the turbo, and here are the degrees on this side of the picture. Clamp the thermocouple wire with the welding pliers and press and hold the button on the welder before you have contact with the mesh block. Approach the wire slowly to the mesh block until they are welded. This is on the lower picture here. After welding, the thermocouple should have a burl shape at the end. If not, you have to do the welding procedure again until it's perfect. This is time consuming. And you need a lot of patience. Direct fastening with a high temperature binding wire, optimal positioning and contacting, and only applicable for round specimen. This is the picture on the left. You need a lot of patience when binding the thermocouples to the sample. Specimen temperature measurement with directly connect specimen thermocouples. This is what we see in the last pictures, in-house production of thermocouples with roll material, connecting via thermocouple connector, compensating cable required for connecting to furnace controller. The advantages remains in the same position, even if the specimen expands. Exactly defined measuring point on the specimen and simple repair possible by welding. Disadvantages: time-consuming fastening only possible with a cooled down furnace or outside of the furnace. Fastening only on round specimen possible. Adjustment and maintenance, the calibration from the thermocouple. Here you can see the standard norms, the temperature ranges, the measurements L0, the type of the thermocouples. The most important standard and permissible temperature deviations here on this page. Direct fastening with high temperature binding wire, samples larger 40 millimeters with take 3 thermocouples. Smaller than 40 millimeters, we use 2 thermocouples, and samples smaller than 20 millimeters, there we use 1 thermocouple. How to attach the thermocouple to the specimen with high temperature bonding wire. There's also a small movie I will show you. Oh, it's wrong. Take the binding wire and pass it through the eyelet of the thermocouple. Place the thermocouple on the sample and wrap the wire around the sample under the pearl. Cross the wire and twist the wire with a small plier. Place the thermocouple in the right position and twist tightly. So now you can see a perfect binding. These 2 example pictures show how the connection should look like. This is time consuming and you need a lot of patience for that. The next page is to calibrate the sample thermocouple with a block calibrator. Temperature range and steps can be set in the wizard of the test program. For an automated calibration, connect the block calibrator to the PC via RS232 connection. Here's also a small movie. Open the screw to slide the Inconel protective cover backwards. Tighten the screw again. Here you can see the thermocouple must be free. Now the thermocouple is plugged to the other thermocouples and the reference element. And now I fix them together. The test specification is opened and the test is started. The first base point is at 100 degrees. Then we move to 200 degrees, 300, 400, until 1200 degrees Celsius. So I think we stop it here. And after the test, the serial number of the machine is entered, and then the TCT files are created. Now, here you can see the calibration protocol with the temperature diagram on the left side from 100 to 1200 degrees. And here you can see the whole temperature values. For each delivered high temperature system, we perform a standardized calibration to increase and ensure the accuracy of the temperature measurement chain. The calibration procedure standardized calibration of thermocouples. Pre-conferred masters test perform enables a standardized process, high accuracy to active use of maximum 16 data points. At this moment, we only have 12 data points. Automated verification of all calibration steps and recording of the measurement values and sample and master thermocouples. Automated creation of calibration table for use in test expert software. Here you can see only calibrated thermocouple. On the left side, this is calibrated, and here on the right side, this is non-calibrated. This is a stable control, and here it is unstable. You can see a calibration record of an external calibration laboratory with calibration values. This is here. This means here we can recalibrate a thermocouple. I will show you in this page. This is a small movie. Here we have a test specification so that we can create the TCT files with the external calibration values. First open the test specification and then enter the serial number of the machine. We have 12 support points to enter. This is now the temperature of the reference. Next one is the temperature for the top. This is the temperature for the middle thermocouple. and finally the temperature for the bottom. Now here you can compare the temperatures again. To create the TCT files, press the button Create TCT Files. Here we can select which thermocouples we want to create. In our case, we say all. Now the corresponding TCT file can be found in the sys folder. Import TCT files into TestExpert. Here you can see O1 TCT is for the top, O2 for the middle, and O3 for the bottom. And here is the sys folder. After recalibration or change of a sample thermocouple, only the new TCT needs to be copied into the TestExpert directory. Here I say the sys file. The new value will be automatically sent to the high temperature controller by TestExpert when a new set temperature is used. This is as simple as it is. Now we came to the FAQs. When one of the three specimen thermocouples is outside of the ±2K range, what is the reason? The relevant thermocouples did not have contact with the specimen. Attach the thermocouple to the standard to be sure to have contact. The thermocouple is positioned incorrectly of the axial orientation of the sample is not centered on the furnace. Make sure that the sample is axially centered to the furnace and the thermocouples are regularly directed on the sample. The difference from the start to the target temperature is too low. As a guideline, the following values may apply. Specimen temperature 25% set value, furnace temperature 75% set value. The heating rate is too high. As a rate is 5% set value per minute. One or more sample temperatures includes 15 to 9 degrees. What is the possible case? One or more thermocouples are broken. Replace the broken thermocouples or replace the valve if it has come loose. Contact fault in the plug on the furnace control. Replace the defect thermocouple to replace the terminal of the circuit in the plug. One or more sample temperatures indicate room temperature, although the oven is heated. What is the possible case? When one or more thermocouple in the insulation is defective, replace the defective thermocouple. The oven could be damaged by overheating. Be careful. The sample temperatures vary greatly. What is the possible case? The thermocouples on the sample are mounted in the wrong order. Before the start of the test by means of hand heat or lighter, I prefer the lighter, if temperature changes in the display in the right place can be registered. The thermocouples in the furnace are mounted in the wrong order. before the start of the test by means of the hand heater or lighter if the changes of the temperature on the display to the right place to be registered. The correct order of the furnace thermocouples can be usually quite easy to tell the collector to the oven by following the cable. The oven heats up, the temperature gauge goes into the negative, but what is the possible case? The wires of the compensation cable or thermocouples probe are reserved in the connector. Open the plug and swap the wires. In the production of extensions is essential to ensure the correct polarity. There will not be displayed traceable temperatures. What is the possible case? The thermocouples actually used does not meet the set in the controller types. Set the controller thermocouples types actually used for the effective inputs or use the set thermocouples as supplied. The set types to the color of the socket can be seen. Okay, this was my presentation. Thank you for attention.
Hello, Thomas.
Yes.
Yeah, I have one question. It's about the welding. If suppose that welding and spot or ball is not proper, then what we have to do?
Please, once again, I can hear once again the welding.
Yeah, if that welding is not proper, then how it will affect in the further results?